Hello everyone, here's JJ. This video, I won't explain some knowledge on textbook, but instead, I will explain some question. The question I think which is tricky or interesting. So let's go. So if you guys still remember the past paper from last week, the fourth question, here's a function like that. X cubed plus 4x squared plus x minus 6, like that. So first we have to find the root of f. So this question we need to use a calculator, but here are some tips. I mean, we can observe the coefficient of this function. What do we get? 1, 4, 1, negative 6. One, 4 plus 4, 1 plus 1, negative 6, minus 6. Okay. After we can calculate this, then what do we get? We get 0. So what does that mean? It means x equal 1 is a root of fx equal to 0. Why? Because when we let x equal 1 and we put it in, all the x to the power of something will become 1, which is like, then the coefficient will left there. Then we can just calculate if the sum of coefficient is equal to 0, it means x equal 1 is a root of this function. Yeah. So after we know x equal 1 is a root of fx equal to 0, it means the function must have a factor which is x minus 1. Because the coefficient of x cubed is 1, therefore we can assume something like that. X minus 1 times x squared plus bx plus c equal to this. Then we can just expand it and compare the coefficient of each term. So let's expand it. Here is x cubed, then minus x squared plus bx squared, then minus bx plus cx, then minus c. Therefore, x is equal to x cubed plus b minus 1x squared plus c minus bx minus c. So let's compare each stuff. We know that. We can know, like, let me show it. So we can get b minus 1 equal to 4, and here we get negative c negative c equal to negative 6. So we get b equal to 5, c equal to 6, and we can check. The thing is, we can check c minus b, 6 minus 5 equal to 1, which is same as here, 1. Therefore, we know that b is 5, c is 6. Then, it's not end, it's not finished. Therefore, we know that it's equal to x minus 1, then x squared plus 5x plus 6. if you have really good feeling about number, then you realize that 5 is equal 2 plus 3. 6 is equal 2 times 6, 2 times 3. Therefore, we can continue to factorize it. Then we get x minus 1, x plus 3, x plus 2. Therefore, the root of this function is x equal 1, x equal to negative 2, x equal to negative 3. So sometimes obversing is really important. We have to obverse the coefficient sometimes. It can simplify our work. So it's the first question. And second question is, if we still haven't learned the derivative, therefore we cannot predict the shape without a calculator, you're just using calculator to sketch the graph, right? To draw the graph. Therefore, you guys can try it by yourself, then we can get the graph. The graph is like that. Like that. I won't put exactly a number on it because I don't have a calculator right now, but I will explain the method. So the graph of f has an inverse for x more or equal to a, where a belongs to real number. Find the smallest possible value of a. So first, we have to know what type of function has inverse. So yes, only one-to-one function has inverse. But the thing is, the whole graph of this function, like this range, between this range, pass through this minimum point. Between this range, this function is not one-to-one. Instead, it's more to one. Therefore, we have to think about it. Like when x more or equal to what, the graph is one-to-one. So the way we can check if the graph is one-to-one or more to one is a horizontal line rule. So look at my arm. So for example, if we only take care of this line, the part at right side of this line, so we can check 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So it's 1-to-1. Then we can check this line. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 till here. Yeah, 1-to-1. Which point is special? The special point is the minimum point, because if we draw a line goes through the minimum point. Okay, this line is vertical. Okay, so it's 1, 1, 1, 1, 1, 1, 1 till here. This horizontal line so at that point, this horizontal line is the tangent of this graph at that point. Therefore, there's also only one intersect. So it means when x more or equal to this point, the graph of f has inverse. But the thing is, if we go a little bit more, like here, so like then we go through here. Here's 2 points. Then it's not 1-to-1, it's more to 1. Therefore, the smallest possible value of a should be x coordinate of this point. Do you guys understand? Okay. And for question C, it's something the method is same, but be careful. That's why we have to read the question. The graph of f has an inverse for x less than equal to b, where b belongs to integer. It's really important because if you guys use calculator to find the maximum point, the x coordinate of this point is not integer. And remember, this number is something like negative 2.5, like that. So here's a really important question. We want to find the smallest integer. It should be the largest possible value of b. Oh, sorry, I'm making a mistake. The largest possible value of b should be -3 or -2, because yeah, b is integer. So I mean, if you have a graph, you don't have to think that much. Obviously, -3. Why? Because here's -2.5, -3 is here, -2 is here. If -2 is here, if the largest possible value of b is -2, you see, it's not 1 to 1, it's more to 1. So obviously it should be -3. But also, if we change the question, like where b belong, if we change where b belong to real numbers, same as question b, therefore the answer, the largest possible value of b should be this point, like something -2.5, blah 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 something. But this asks the largest possible value of b. Therefore, we try to find the largest integer which less than -2.5. So this one should be -3, but not -2. Does that make sense?